Hi, welcome to my new unit on piecewise defined functions. In this first video, we will talk about the definition of a piecewise defined functions. The definition of piecewise defined functions. First of all, I have the word defined here in that you are given the values of the domain for each part. A function, the piecewise means piece, a function made up of parts with individual intervals for each part. And let me explain that. Number one, I have the f of x equals bracket, and I have two parts. One is with x, and that's greater than or equal to 2, and I have a negative 1 when x is less than 2. So we want to look at these two, or this one with these two intervals. So the first one, if you take 2 is equal to 2, put a 2 here. So this equation, we can also just skip back, sorry about that. The f of x could be a y, so it's y equals. So this could be x and y, or we could also have the f of x, which is the y. So if we take a 2 and put it here, we get x is equal to 2, so 2, when x is 2, y is 2. So when x is 2, y is 2. Now we take x is 3. When x is 3, y is 3. X is 3, y is 3. And we take a 4. When x is 4, y is 4. X is 4 here, y is 4. Let's say it's right there. So it's equal to, so this is a solid dot, and it's doing this. So there it is. And you notice this first expression here is y equals x. So y equals x is a line, linear, which has a y-intercept that's 0, with a slope of up 1, right 1. So y-intercept is 0, you go up 1, right 1, up 1, right 1, up 1, right 1, and so on. But we can only start where x is 2, so it's equal to 2, so this point is included, and all points to the right. Let's look at the second part. And again, the second part is y is equal to negative 1. So x cannot start at 2, but a 2, when x is 2, we have a negative 1. So when x is 2, we have a negative 1. So that 2 is here, giving you this value of 2. So this point, we cannot have a 2, so it starts with a hollow dot. So this is the point of 2, negative 1. Now, x is 1. When x is 1, y is negative 1. When x is 1, y is negative 1. Less than, let's take a 0. 0 is negative 1. When x is 0, y is negative 1. When x is negative 1, y is negative 1. So notice that this is a horizontal line. Y equals negative 1. So it's a horizontal line that's going like this for all points to the right of 2. Sorry, to the left of 2. But it's not, there's a hollow dot, means this point right here. This point 2, negative 1 is not included. But it's a horizontal line. So this is what we call the piecewise function made up of two parts with individual domains. Let's look at another one, f of x equals, and here we have three parts. So negative 2x plus 4 when x is greater than 0. So notice this is a linear. Y equals mx plus b, so it's a line. X equals 0, we have another linear again, but we got to be careful here. We only have x equals 0. So that's only the value when x is 0. And this one is the absolute value when x is less than 0. So we have three parts. Let's graph each part. So we can't start with 0 here, but if we put a 0 in here, we'll get a 4. Negative 2 times 0 is 0. 4. So 0 right here gives me a 4. So, but that point is not included because it's not equal to 0. Now, we have to take greater than, so we pick a greater than 0, let's pick a 1. We take a 1 and put it in. Negative 2 times 1 is negative 2, plus 4 is 2. So 1 gives me a 2. So it's right there. Then we take a 2. We keep going to the right. So put a 2 in here, we get a negative 4 plus 4 is 0. So 2 gives me a 0. So you can see that this is a line that starts at the y-intercept of 4 and is going down to right 1 with a slope of negative 2. So down 2, right 1, down 2, right 1. We continue. So we start here, and there it is. So this is a line that's starting here. Instead of going on up here, we can't, because we can only start at 0, but this point is not included. So when x is 0, then we put a 0 in here. We get 3 times 0 is 0. We get a negative 1. So when x is 0, y is negative 1. When x is 0, y is negative 1. When x is 0, x is 0, y is negative 1. So this is a point. Even though this is a linear, but we can only look at when x is 0. We can't look at when x is 1, 2, negative 1, negative 2, etc. Only when x is 0. So there's the point. And we have an absolute value. Absolute value is always positive. So let's look at when x is 0. Put a 0 in here. The absolute value of 0 is 0. So we have a 0 right here, an absolute value. So that's a hollow, because is not equal to. Now we got to go less than. Put a negative 1 here. So a negative 1 right here will give me, the absolute value of negative 1 is a 1. So negative 1 will give me a 1. Put a negative 2 in, less than 0. Negative 2, absolute value is 2. Negative 2, we get a 2. So notice it's hollow here, but this is the left side of the absolute value. There it is there, because an absolute value is a V shape. If you go on this side, which we can't, right now we can't, but if you could go over here, then if you've had a 1, the absolute value of 1 is 1. If you 2, absolute value would be 2. So an absolute value would be this V shape, but we're only can pick to the left of 0, but not 0 itself. So there's a hollow dot, and a solid dot. So that's the graph representing this piecewise function. And another way to represent the piecewise functions is to find some values, not having to graph, as in this illustration on this page. The p of x equals 4x minus 1 when x is greater than 2. The absolute value of x is when x is less than or equal to 2. So we want to find the p of 3. Look around, 3 fits here. So we have to put the 3 into this function. So 3 goes into place of x. So that gives us 12 minus 1. So that gives us 11. So the p of 3 is 11. Now we look at 2. 2, that's greater than 2. This is equal to 2. So when p is 2, we look at this because x is equal to 2. So we look at the absolute value of 2, which is 2. And a negative 4, the p of negative 4, x is negative 4, not here. Negative 4 fits here. So it's the absolute value of a negative 4. So we have to put negative 4 into here because of this interval. Absolute value of negative 4 is 4. And let's do some more. The h of x, we have 3 of them. And again, it's x squared plus 2 if x is less than 0. So that means less than 0, like a negative 1, negative 2, negative 3. Equal to 0, we have a 1. And greater than 0, we have to look at negative 1/3 x plus 4. So when h is 0, 0 is here. That means that the y is 1. 9 fits here. 9 is greater than 0, so 9 goes in here. So negative 1/3 bracket 9 plus 4. Multiplication first. 1/3 of 9 is a negative 3 plus 4 is 1. So the h of 9 is 1. Negative 6, greater than 0, no. Equal to 0, no. Fits here. Negative 6 fits in this one. So it's negative 6 squared plus 2. Negative 6 squared is 36 plus 2 gives me 38. So notice the piecewise function, whatever number or value I give you for x, it fits in one of these three. And we have another one. F of x equals the square root of 7 subtract x when x is less than or equal to 7. And it's x minus 3 when x is greater than 7. So what about the f of 11? And 11 is less than 7. Nope, 11 fits here, greater than 7. So it's into x minus 3. So 11 goes into place of x right here, minus 3. And 11 minus 3 is 8. And the f of negative 2 fits, nope, that's greater than 7, nope, fits here. Negative 2 fits in x is less than or equal to 7, so it fits in here. So we have to go square root, and we're putting a negative 2 in, so it's 7. So x is negative 2 right here. So that becomes negative, and negative is a positive. That becomes the square root of 9, which is a 3. So that's a little bit an introduction to the piecewise function, defining it. Remember, piecewise function is made up of parts, with each part having an individual domain or value of x. And we graph it over that interval. And again, if you like my video, click the like button, click the subscribe button, and visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Just one word. Thank you for viewing my video. Hope the video helped you. Bye-bye.